Hello friends, today we have very interesting topic that is very usable for the engineering geology and known as rock quality designation. This rock quality designation was given by Deere in 1967. So this is very popular in the form of RQD. RQD is basically usable for the borehole logging as well as for the surface mapping also, and this is a very important factor to calculate or to classify the rock into different type of rock mass classification as rock mass rating, Q system, etc, etc. And RQD is also very important to know the subsurface geology, and RQD give the idea about the damage zone as well as some fractured zone also in the subsurface. So RQD is very important for the mining purpose as well as for the civil engineering purpose. This is usable in the mega civil structure like tunnels, highways, railway tunnels, okay, then road tunnels and water conductor tunnels, HRT, that is known as headrace tunnels, and dam foundations also. So RQD is very important. So based on the percentage of the RQD, we can classify the RQD into five categories: very poor to excellent on the 25%, 25 to 50%, 50 to 75%. So here we have a formula. With the help of this formula we can calculate the RQD in the borehole. So here we have to add the core pieces, those have length more than 10 centimeter, and divided by total drill runs. This drill run is basically depend on the type of used rig in the during the investigation. So the total drill run can vary from 1.5 meter to 2 meter, 3 meter, or more than that. It's depend on the use rig. Then it should be multiplied by 100. So this total value RQD comes into the percentage. Okay, so here we have RQD and the rating also. This rating is usable to calculate the different type of rock mass rating like RMR and Q value. We will discuss in the upcoming videos how we can calculate the RMR and Q system, and how the question comes in the different types of competitive examination. So here let's take an example. This is we have a drill hole. This is a very good sketch, and we have lots of fracture here also. You can see along this one and this one and this one. So these fractures are natural fractures, and here we have lots of high fracture frequency, we can say. Then again we have a natural fracture, and this one is the mechanical fracture. So question come arise, how we can differentiate between natural fractures and the mechanical fractures. Mechanical fracture is basically formed due to the mechanical activity or due to the human error during drilling. So it's not a nature fault. So we means consider it as a intact rock. So if suppose that we have a mechanical fracture in this core, so we have to calculate the length of this core from here to here including the mechanical fracture. So that's why the length of this core is 43 centimeter. But in the case of natural fracture, the surface of the natural fracture should be discolored, or maybe weathered, iron stain, or maybe we can get some secondary mineralization zone or secondary mineral iron stain, chloritic surface that may be smooth also. And if we try to fix it, or if we can't to add it or joint it, it can't be properly fit to its broken part. But in the case of mechanical breakage, we can fix it, or it looks like that it's never we can fix it without any loss. So here we have to calculate, or we have to add the core pieces, those have length more than 10 centimeter. Let's take an example here. This is RQD, and then we have to add the core pieces length, those have more than 10 centimeter, that is 38, 17, 20, 43, and divided by total run. Here total run is 2 meter, and we can convert 2 meter into centimeter, that is 200, then multiply by 100. So if we calculate the RQD here, it will come 59%. So 59%, based on the classification, we can put 59% into fair rock class. So RQD will classify the rock class, and this rock class is basically usable for the civil engineer, because we are the geologist and we are the mediator between the rock and the civil engineer. So we convert the language of the rock to the numbers, and these numbers are usable for the civil engineers. Now we have a secondary method. Now we have a picture of the borehole drill. So here we have lots of pieces, and these pieces have length less than 10 centimeter. Even we can see we have lots of fractures, and these fractures are discolored. We can see these are not fresh, so these are the natural joints. So that's why we are not considering these pieces as a single rock joint. So we have a secondary method, and this secondary method is usable to calculate the RQD during the surface mapping. So here formula is 1 RQD is equal to 115 minus 3.3 into JV. So JV is the number of joint per unit volume. So here we have a exposure, we have an exposure here. So in exposure, if we mark 1 meter length, 1 meter cube area, and we calculate the present number of joint in this, that is known as JV. So based on the JV we can classify the rock into different types. If suppose that we have a number of joint less than 1, that is very large block, then 1 to 3 large blocks, 3 to 10 medium size block, 10 to 30 small blocks, and more than 30 very small blocks. So basically very small block is very we can say very fragile in nature, and it's means very difficult to support these blocks. So that's why we can calculate the JV here. Okay, so we can put the value of the number of joint per unit volume here, and can classify the rock according to this classification. We can put the rock into different 5 class. Okay, so this is secondary method, and this is very usable. So RQD is also very important for the examination point of view also, because in different examination this RQD question had come already. So they can give you the example of the different core sizes and can ask about the RQD value, or it may possible that they can give the core piece length value into the pieces, into the percentage. Means if maybe it is possible that 42% of the core pieces has length more than 10 centimeter. So what will be the RQD? So if such type of question has come, you can solve very easily. So with this note, I'll be very thankful to you for listening me very carefully. I hope you will enjoy this video, and I will come with the next video very soon. Then thank you.